Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I am teaching physics, chemistry and mathematics starting from 8th standard to 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So now we will try to understand what are all the laws of motion which was stated by Newton. So before going into the laws of motion, first we will understand what was the Galileo's idea about motion. So here let us consider an example. So there is an inclined plane like this, and there is one more inclined plane with same inclination angle on the other side. Here also angle theta is there, and here also angle theta is there. That is, the plane of inclination has same angle on both the sides. So now if you release a particular marble from this particular height, and assuming that this particular surface has no friction. So ideally this is not possible. As of now, to understand this particular motion, we will think that this particular surface doesn't have any kind of frictional force. Only gravitational force is acting on this particular marble. So now if this particular marble is dropped from this particular height, so due to gravitational force, it will reach this particular bottom of the inclined surface, and by the time when it reaches bottom of this particular inclined surface, it will attain certain amount of definite velocity, and because it is already there in a certain amount of definite velocity, this particular marble will again starts climbing the other inclined plane and reaches the maximum height wherever this particular ball was released on the other inclined plane. So for example, if this particular ball has released from an height of 20 or 10 meter, then it will reach the same 10 meter height on the other inclined plane as well. That means here the velocity which it has gained at the time of rolling down this plane, with the same velocity it tries to climb this particular inclined plane, and as it goes on climbing this particular inclined plane, because of gravitational force which is acting upon this marble, the velocity goes on decreasing as it goes on climbing the second inclined plane. It reaches the maximum height, and again due to gravitational force it comes back to this particular position, and again because of this velocity which it has gained, it will again climb the other inclined surface and it reaches the same maximum height. And this process will be continuously going on if this particular surface is non-friction surface. That means no frictional force should be acting on this particular marble. Then only this particular process will be keep continuing unless and until an external unbalanced force is applied on this particular marble to make the state of motion of that particular marble come to rest. So now we will go further deep into this particular concept. So let us assume only one inclined plane is there like this with the angle theta, and there is no other inclined plane for this particular marble to climb. So now if you release this particular marble from this particular height, and we should assume that this inclined surface and this particular surface is having no friction. So that means zero frictional force should be applied on this particular marble. So now if you release this particular marble on this kind of surface, it reaches this particular position and it travels in this particular positive x direction. And one thing you should remember here, Galileo argued that if there is no frictional force on this particular surface, then this particular object will be keep continuing to move on this particular surface with constant speed. That means whenever a particular object is moving with constant speed on a particular frictionless surface, then this particular object will be keep continuing to move in that constant speed on that particular surface. So here this particular object will reach a particular constant speed, or you can call this as uniform speed. So let us assume there is an object lying on a frictionless surface. So always remember this particular surface doesn't have any kind of friction. So this is frictionless surface. So on this frictionless surface, if there is an object and if you apply small amount of force F on this particular object will change its state of motion from rest and it starts moving. That means this particular object will come into the state of motion. So now when this particular object is moving on this particular surface, after a point when this particular force effect is not there, then this particular object attains constant velocity. So this particular object achieves constant velocity after a point. So let's say from this particular point with constant speed, because there is no unbalanced force which is acting upon this particular object. So whenever if you want to bring this object to rest, then an opposite force should be applied on this object to make this object come to rest. So now this particular object is moving with constant speed. In order to bring this object to rest, the unbalanced force will be helping us. That means an external force need to be applied in the opposite direction to the direction of motion, so that this particular object will come to rest. So in practical situations, what happens is that if you have a surface like this, and if you put certain amount of force on this particular object, after traveling a certain distance, this object comes to rest. Why? Because the force which is applied on this particular object, the frictional force which is there on this surface will be acting opposite to this particular force. Then this particular object comes to rest. That means here on this surface which has friction, the frictional force by the surface is acting as the unbalanced force. Here this particular frictional force is acting as an unbalanced force for this particular applied force, and hence this particular object is coming to rest. So, but in the other case, there is no external unbalanced force which is actually making this particular object come to rest or to the state of motion. That means unless and until there is no external force acting on the object, that particular object will continue to be in the whatever state it is in. Now we can assume this as frictionless surface. So if this frictionless surface is there, and if you are applying a necessary amount of force, unless and until you apply this particular force F on this particular object, this object will continue to remain in rest. So only when you apply this force to this particular object, then only this particular rest state is broken and this comes to a particular state of motion and reaches uniform speed. And this particular uniform speed will be keep continuing unless and until there is some external force which is acting upon this particular object. So let's say if there is an object, and unless and until an external force is acted upon this particular object, this particular object will be continue to remain in uniform speed unless and until this particular external force is applied. If this force is not applied, then this keeps continuing in its uniform speed. That means in this particular state, it is having constant speed or uniform speed. And at this particular point, this particular object is at rest. So if you want to bring a particular object, so let's say there is an object. If you want to bring this object, if you want to break the rest state of this particular object, then you should apply some amount of force. So then you should apply some amount of force F, then only this particular rest state will be broken. So only when you apply certain amount of force, the state of rest of a particular object is converted to be in a particular state of motion. After certain time, this particular object reaches uniform speed. So let's say if this particular object now it is moving with uniform speed. In order to break this particular state of motion, so this is one particular state of motion. So now uniform speed is also a particular state of motion. To break this particular state of motion, again you have to apply external force. So again you should apply force. Now this is case 1. So where you are actually breaking the state of rest of a particular object to make it come into the state of motion. So now in case 2, this particular object is already in the state of motion with constant speed, with uniform speed. In order to change that state of motion, that means either you should accelerate this particular object or you should bring this object into rest. That means this uniform speed should be either increased or decreased, or it should be brought to rest. So in order to change this particular state of motion, you should break the state of motion by applying the external force. That means this particular state of motion is changed. Break means it is actually getting changed. It is not getting braked. It is actually changing from one particular state of motion to the other state of motion by applying external force. This is actually governed by Newton's first law of motion. So now we will go into the definition of Newton's first law of motion. So what is the definition given in the textbook for Newton's first law of motion? Here they have given an object remains in a state of rest. So here I have given the first case where the object was at the state of rest. So in this law we are actually coming across an object remains in a state of rest or in the state of uniform motion. Here I have given the second case where this particular object is having uniform speed. So when an object is said to have uniform speed, then that particular object will be having uniform motion. So that means here two cases we are taking. One is an object remaining in the state of rest, and the object remaining in the state of uniform motion will keep continuing in that particular state unless and until there is an applied external force. Only when you apply a certain amount of force, the state of rest will be changed to the state of motion. And when a particular object is in uniform motion, only when you apply certain amount of force to that particular object which is having uniform motion, either it will accelerate or it will decelerate and come to rest. That means if a particular object is in uniform speed, here I have already shown. So this particular object, if it is there in uniform speed, then this is in a particular state of motion and it keeps continuing in that state of motion unless and until the external force is applied. So this particular state of motion is changed only when applied force is there. That means only when you apply force from opposite direction, it comes to rest. Or if you are applying force in the same direction in which the object is moving, then that particular object will be accelerated. So that means in both the cases, the state of motion is changing because of the applied external force. So this is actually the Newton's first law of motion. So this particular first law of motion is also known as law of inertia, because when a particular object is in state of rest or in state of motion, then it will have certain amount of inertia in that particular object. So what do you mean by inertia? So this particular inertia is the resistance to change its state of motion. So always you should remember this inertia is resistance from an object to change its state of motion. So now if you are applying a force which is actually breaking this particular resistance to change its motion, its state of motion, any object's state of motion, then that means you are applying that much amount of force to break the inertia and to change the state of motion of that particular object. For example, if it was at rest, then it comes to the state of motion, and if it was at already in a state of uniform motion, then it will be accelerated or it will come back to rest. So that means here an object's initial state of motion will be having certain amount of inertia, which you should actually break by applying external force in order to break that particular inertia and change the state of motion of that particular object. So that is what is said in the Newton's first law of motion. Hence the Newton's first law of motion is also known as law of inertia, because you are actually breaking that inertia in that object which is there by applying an external force. So this is all there in this particular video. The next concepts which are there in this particular chapter I'll be teaching in the subsequent videos. Until then, if you want to learn more physics, chemistry and mathematics, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.